providing process to process communication. Okay, so for example, let's say when you are searching something, so on your PC or on your laptop, your Google Chrome is working as your one process. Okay, and at the server side, when you are searching something, that HTTP process, or we can say the HTTP server, is running as another process. Okay, so communication between these two processes can be done by the transport layer. Okay, so we can say that transport layer is mainly responsible for process to process communication, or we can say that it is mainly responsible for end-to-end delivery. Okay, so when we are talking about the network layer, we know that we have the various protocol like the IP, ICMP. So all these protocols are implemented at source, at the destinations, and in between all the hosts through which your data is going to be passed. Okay. While in case of the transport layer, we have only two protocols, that is TCP and UDP, that are going to be implemented only at the ending side. Okay, so that means only at the source and only at the destination. Okay, so we can say that transport layer is responsible for providing services to the application layer, and it receives service from the network layer. Okay, now transport layer responsible for process to process delivery. So the delivery of a packet or a part of a message from one process to another. Okay, for example, let's say if you are sending some mail, okay, if you are sending some mail, so at sending side, your browser is going to be working as the sending process, and it will generate some chunks of data, or we can say that it will generate some type of message, so that are going to be divided into the various segments, and that segments are delivered to the transport layer. Okay, then the transport layer will provide that data to the receiver side, and receiver will again collect all the segments and create the new message. Okay, so we can say that the two process can communicate in a client-server relationship. Okay, so when if you are talking about, let's say, any web application, so for any web application, we are following the client-server relationship, in which your source, your we can say that your own device is working as the client, and the opponent devices, okay, from which you are getting your data, that is working as the server. Okay, so at the client side, whatever the client process is there, that is working as the client, and at the destination side, whatever process is there, that is working as the server. Okay, so here you can say that here we have the client and here we have the server. We can say this one is source and this one is the destinations. We know that the various processes are going to be run at the client side, and the various processes are going to be run at the server side. Okay, so what is the meaning of this process to process communication? So we can say that one process at the client side is communicating with one process at the server side. Okay, for example, let's say we are talking about this HTTP server. Okay, when we are searching something on the Google. Okay, so at that time we are connecting with the HTTP server. Okay, so at the client side you have the one process, let's say Google Chrome. So your Google Chrome is communicating with the HTTP server, that is known as the process to process communication. Okay, so what is the meaning of the network layer protocol, and what is the responsibility of the transport layer protocol? So we can say that when there is a communication between the client and server, okay, so we know that the network layer is responsible for host to host communication. Network layer is responsible for host to host communication. That means we can say that the whatever network layer protocols are there, IP and ICMP, that are going to be work between the client and the server. Okay, while the transport layer protocols are going to be work between the process on the client and between the process on the server. Okay, so we can say that the domain between the client and server can be handled by the network layer, while the domain between the process on the client and the process on the server, that can be handled by the transport layer. Okay, okay, now okay, so one more thing about this thing is, let's say if you are following a multi-processing environment, okay, So we can say that in the multi-processing environment, we can have multiple processes that are going to be run on multiple devices. Okay, it may possible that here we have the server. That server is also going to be running one HTTP server, one FTP server, one SMTP server. Okay, so the task of this transport layer is to select the particular server, and then based on the selected server need to perform the communication. Okay, so you can have question that how we can identify that on which server we have to perform the communication. Okay, so answer is for that we require the addressing. To identify the particular server, we require the addressing, and for the addressing on the transport layer, we are using the port numbers. Okay, so up till now we have gone through the three type of addressing that we have seen the MAC address on the data link layer, we have seen IP address on the network layer, and now we are going through the port numbers, or we can say that the port address on the transport layer. Okay. So a process on the local host called a client needs services from a process usually on the remote host called a server. Okay. So here we can say that there is a concept of local host and remote host. Local host can be considered as a client, while the remote host can be considered as a server. However, it is said that operating system today support both multi-user and multi-programming environment. Okay. So what is the meaning of multi-user? So we can say that on the same laptop, or we can say same desktop, it may allow the multiple type of users. Okay, you can have a guest account, you can have a administrative account, you can have a different type of user account. Okay, and each account you can have a multiple programs are going to be run. For example, let's say in my account I have installed the Google Chrome, and let's say I am using the communication for Google Meet. Okay, same way for the administrative account, so many other processes are there. Okay, while same way for the remote computer can run several server programs at the same time, just as several local computers can run one or more client programs at the same time. Okay, same way suppose આપણું જે remote computer છે, or we can say આપણું server છે, that is also running the several server programs. As I have said that let's say on the remote computer one HTTP server is going to be running, one FTP server is going to be running, one SMTP server is going to be running. Okay, so that means for communication we have to define four things, that is the local host, local process, remote host, and remote process. Okay, so that means the local host means our own computer, remote host means the server from which you want to access some data, local process मतलब આપણા ડિવાઇસ પર આપણે જે કંઈ પણ એપ્લિકેશન રન કરાવતા છે, that is known as the local process, and the remote process मतलब આપણા સર્વર પાસેથી આપણે જે સર્વર પાસેથી ડેટા એક્સેસ કરવા માંગીએ છીએ તે ડિવાઇસીસ તે પ્રોસેસ. Okay, so we can say that the local host and remote host are defined using the IP addresses. Okay, while to define the processes we need a second identifier that is called as port numbers. Okay, so in the TCP/IP protocol suite, the port numbers are integers between 0 and 65535. Okay, the size of the port number is 16-bit. Okay, the size of the port number is 16-bit. That's why we can say that the possible value of the port numbers are from 0 to 65535. Okay, so we can say that the client program defines itself with a port number that is called as ephemeral port number. Okay, so the word ephemeral means short-lived and is used because the life of a client is normally short. For example, let's say when you are performing any communication at your own PC, okay, when you go into the task manager, then you can see that the various types of processes are going to be run. Okay, so here let's say, just wait a minute. Okay, So here you can see that this is the task manager of the client. Okay, so here you can see that the various types of processes are going to be run, and every process has assigned some process ID. Okay, for example, let's say in my account I have my own account plus I have the system account. Okay, so in my account I have started the Chrome, and also in the Chrome I am running the various types of processes. Let's say in the one tab I have opened the mail server. In the another tab I am communicating using the Google Meet. Okay, or let's say one more tab I have opened the Google, so in which I am searching something on the Google. Okay, so we can say that for each process they have assigned some process ID. So this type of processes ID are known as ephemeral port numbers. Okay, અહીંયા જે આ ટાસ્ક મેનેજરમાં આપણને પ્રોસેસ આઈડી અસાઇન થયા છે એને કહેવાય ephemeral port numbers. Why it is known as the ephemeral? So the meaning of ephemeral is short term. That's why we can say that these process ID are assigned by the operating system, and this process ID are short-lived. That means we can say that this process ID are generated by operating system, and it is going to be used for some type of application. જ્યારે આપણે application બંધ કરી દઈએ ત્યારે આ બધા process ID નીકળી જાય. Okay, so this type of process ID or port numbers that can be used at the client side, these are known as the ephemeral port numbers. Okay, while at the server side we have to use some port numbers that should be previously defined. Okay, so for example, let's say if you want to connect with the HTTP server, okay, so it may possible that we can make such type of mechanism in which HTTP ने रन टाइम एक पोर्ट नंबर असाइन થાય, પછી એ પોર્ટ નંબર આને ક્લાયન્ટ ને મોકલવું પડે, પછી ક્લાયન્ટ એ પોર્ટ નંબર નો યુઝ કરીને કનેક્ટ થઈ જાય HTTP સાથે. Okay, so this type can be mechanism we can implement. Okay, but if you are implementing in such a way, it will create the more overhead. Reason is જેટલી વાર આપણે સર્વર સાથે કનેક્ટ થવું હોય તો સર્વર એક પોર્ટ નંબર જનરેટ કરવા પડે અને એ પોર્ટ નંબર આને ક્લાયન્ટ ને મોકલવું પડે. Okay, so rather than using that approach, what they have done, they have decided some universal port number for servers. Okay, for example, let's say for HTTP they have defined some port number, for DNS they have decided some port number, for FTP they have decided some port number. So these are called as well-known port numbers. Okay, these are known as the well-known port numbers, and we cannot change the value of that port numbers. Okay, for example, let's say at the transport layer we have the three process, and at the transport layer of server we have the three processes. Okay, now here we are using the daytime server. So for the daytime server they have assigned the port number as 13. Okay, they have assigned the port number as a 13, and this is the daytime client. So here the operating system has generated one port number, that is 52,000. That is 52,000. Okay, so when we are sending some data, we can see that in the sending port we have stored the value 52,000, and the receiving port we have stored the value 13. Okay, so we can say that these are the some well-known port numbers, while these are known as the ephemeral port numbers that can generated by the operating system. Okay, so these are the port numbers that can change its value, while the server side, whatever port numbers we are going to be used, that are fixed, and we cannot change the value of the port numbers at the server side. Okay, so now you should be clear about the IP addressing and the port numbers. IP address શાના માટે यूज થાય તો પર્ટિક્યુલર હોસ્ટ ને સિલેક્ટ કરવા માટે, અને પોર્ટ નંબર શાના માટે यूज થાય તો એકવાર IP એડ્રેસ થી આપણને ડિવાઇસ ખબર પડી ગઈ, પછી ડિવાઇસ પરથી આપણે પર્ટિક્યુલર પ્રોસેસ ને આઈડેન્ટિફાઈ કરવી હોય તો એના માટે વી રિક્વાયર ધી પોર્ટ નંબર. ઓકે, ફોર એક્ઝામ્પલ લેટ્સ સે કે આપણું એક પેકેટ આવ્યું છે, એમાં our IP address is 193.14.26.7 and our port number is 13. Okay, so using this IP address we can identify this particular machine. Okay, using this IP address we can identify the particular machine. Okay, but એકવાર આપણું મશીન આઈડેન્ટિફાઈ થઈ ગયું, એના પછી we need to identify the particular process કે આપણે સર્વર બાજુ કોની સાથે કોમ્યુનિકેશન કરવાનું છે. Okay, So for that we require the port number. Let's say port number is 13, मतलब server बाजू આપણી આ process છે જેનો port number છે 13. So we can communicate with this process ID. Okay. So this is the meaning of IP address versus the port number. IP address is used to identify the particular host, while the port number is used to identify the particular process on that host. Okay. Okay. So as I have said that the port numbers are ranged from 0 to 65535. Okay. Port number ની value છે આપણી 0 થી લઈને 65535 સુધી. Okay. So in which they have defined some ports that are fixed, that is 0 to 1023. These are known as the well-known port numbers. Okay, that means these are the port numbers that are assigned to the particular server processes. For example, આપણે HTTP માટે port number use કરીએ છીએ 80. Okay, so same way FTP માટે આપણો port number છે 23. Okay, SMTP માટે આપણો port number છે I think okay, that we will see. Okay, so मतलब આવી જે કોઈ પણ well known process છે like આપણું FTP છે, HTTP છે, SMTP છે, for all that they have defined some fixed port numbers, and that values are always from 0 to 1023. Okay. The second category is registered port numbers. Okay, so there is one authority called ICANN. Okay, so that we have seen in the network layer. So this ICANN is also defining that the IP addresses that we have used for the NAT. Same way, this authority has also defined the categories of the port numbers. Okay, so this 1024 to 49151. So these are the port numbers that are registered with the ICANN. Okay, while the port numbers from 49152 to 65535. So these are known as the dynamic or private port numbers. So this can be used by the particular host at the client side. The client side આપણે જ્યારે કોઈ પણ એક process run કરતા હોય, at that time they will assign the port numbers from 49152 to 65535. So by that way they have defined the three categories of port number, that is well known, register, and dynamic or private. Okay. Okay. Now when we are performing communication with the server, we need to define the two things. The first thing is the IP address and second thing is the port number. IP address થી આપણને particular host મળે અને port number થી આપણને host પરની process મળે. Okay, so we can say that we need to define the both things, that is IP address for and the port number for to perform the communication between the two processes. Okay. So the combination.
Sir,
हाँ बोलो.
सर स्क्रीन विजिबल नहीं है.
नहीं विजिबल.
नहीं सर, 5 to 6 मिनट्स तो नहीं है.
Okay. Is it visible?
Yes sir.
Okay. Okay. So we were at this ephemeral port number. So ephemeral port number આપણા client બાજુ use થાય. Okay. So આપણે જોયું કે task manager માં જે કોઈ port number છે, these are known as the ephemeral port number. मतलब ephemeral port numbers are assigned by the operating system, while બીજા port number છે તેને કહેવાય આપણા universal port number. So universal port number मतलब આપણે જે server બાજુથી જે કોઈ process ને access કરવાની છે, so for that they have decided some port numbers. These are known as the universal port numbers. Okay, so we can say that client બાજુ આપણી એક process છે અને server બાજુ આપણી એક process છે. તો client થી server બાજુ આપણે કોઈ પણ data મોકલવો હોય, so we are creating one message. તો message ની અંદર આપણે source port માં define કર્યું છે 52000 અને destination port માં આપણે define કર્યું છે 13. Okay, so we can say that when your data is reached to the particular destination, so using that 30, it can identify the particular process. Okay, so generally this 13 is mainly used for daytime server. Suppose આપણે real time day and time ની value જોઈતી હોય, at that time we can use this daytime server. સપોઝ આપણી કોઈ એપ્લિકેશન છે એમાં આપણે કોઈ ડે ટાઈમ રિયલ ટાઈમ મતલબ જે આપણે એક્ઝિસ્ટન્ટ મતલબ એ લાઈવ આપણો ડે ટાઈમ છે એની વેલ્યુ જોઈતી હોય એટ ધેટ ટાઈમ વી કેન કનેક્ટ વિથ ધ ડે ટાઈમ સર્વર એન્ડ વી કેન ગેટ ધી વેલ્યુ. ઓકે, so we can say that using the IP address we can identify the particular machine, and using the port number we can identify the particular process on that particular machine. Okay, so IP address થી આપણને મશીન મળશે અને પોર્ટ નંબર થી આપણને જે પર્ટિક્યુલર ડિવાઇસ પરની જે પર્ટિક્યુલર પ્રોસેસ છે તે મળશે. Okay. One more thing I have discussed is we can divided these port numbers from three parts, that is well known, registered and dynamic or private. Okay, so એમાંથી 0 to 1023 છે that are known as the well known port numbers. For example, જે આપણી well known server છે like the HTTP, FTP, SMTP, so for that they have decided some well known port numbers. So these well known port numbers can't be used by any of the devices. Okay, while this 1024249151, these are the registered port numbers with ICANN, while the 49152 to 65535, these are known as the dynamic or private port numbers. That means these are the port numbers that can be used by the operating system when you are searching something on Google, or we can say when you are using any of the networking applications. Then at the client side 49152 થી લઈને 6553 માંથી કોઈ પણ એક એડ્રેસ અસાઇન થશે. One more thing we have seen is socket address. So socket address is nothing but we can say the combination of IP address and port number. Okay, so combination of IP address and port number that is used to identify the particular process on the particular host. Okay, so for example, the client socket address defines the client process uniquely, just as the server socket address defines the server process uniquely. Okay, so generally જ્યારે પણ આપણે socket address ની વાત કરીએ at that time we have to consider two things. The first thing is the IP address and second thing is the port number. Okay, so આ ડિવાઇસ પરની આ પ્રોસેસ, ઓકે, આ ડિવાઇસ પરની આ પ્રોસેસ એ ટાઈપનું આપણે કઈ ઇન્ફોર્મેશન જોઈતી હોય so at that time we can use the socket address. Okay, we will make one good program in a lab, okay, that is known as the chatting application using the socket programming. Okay, so at that time we will see that we need to provide this both thing, that is the IP address and port number at the client side. Okay, but at the server side we require also at the server side we require the IP address and port number. Okay, so we can say that this combination of IP address and port number that is known as the socket address. Okay, so what are the responsibilities of the transport layer? The first responsibility of the transport layer is encapsulation and decapsulation. Okay, so what is the meaning of encapsulation? So we know that the process of adding the header, okay, header add કરવાની પ્રોસેસ એને કહેવાય encapsulation અને header remove કરવાની પ્રોસેસ એને કહેવાય decapsulation. Okay, so we have seen that the transport layer will receive the services from the application layer and provide the service to the network layer. Okay, for example, at the application layer we have the one process. Okay, so for example, let's say કે આપણે અહીંયા use કરીએ છે એક mail server. Okay, so let's say we have opened the Gmail. Okay, client બાજુ આપણે એક Gmail open કર્યું છે. So Gmail is considered as one process. Okay, so in Gmail if you are sending some mail, so it has generated some message. Application layer पर एक process है which we consider that this one is the Gmail. So Gmail एक message generate કર્યો છે. Okay, so that message will be delivered to the transport layer. Okay, so transport layer will divide this message into the various segments. We'll see that this message is divided into the various segments, or it is also known as the packets. Okay, and for each segment they will assign some header values. Okay, so header માં કઈ value આવશે? So પહેલી વેલ્યુ છે આપણી સોર્સ પોર્ટ અને ડેસ્ટિનેશન પોર્ટ. ઓકે, તો સોર્સ પોર્ટ નંબર that means સોર્સ પ્રોસેસનો આઈડી અને ડેસ્ટિનેશન પોર્ટ નંબર મતલબ આપણો ડેસ્ટિનેશન પ્રોસેસનો આઈડી. ઓકે, so this can be assigned by the transport layer. and also some other header information is there that we will see when we learn about the TCP and UDP. જે રીતે IP માં header માં ઘણી બધી value હતી, okay? IP અને ICMP માં same way transport layer પર પણ જે કોઈ પણ protocol છે એના header માં ઘણી બધી information હોય છે, okay? તો એમાં એક information હોય છે આપણું source process ID અને destination process ID, okay? Or we can say that source port number and destination port number, okay? So using that, we are making one logical connection between the transport layer of the client and the transport layer of the server, okay? On the receiving side, we have to remove the header. So header remove કરીશું આપણે, then આપણને ખબર પડશે કે સર્વર બાજુ ઘણી બધી પ્રોસેસ છે, એમાંથી કઈ પ્રોસેસને આપણે ડેટા આપવાનું છે, okay? So for example, let's say if you are connecting on mail server, okay, SMTP server. So for SMTP, let's say our port number is 23, okay? Port number is 23. So in your destination port number we got the value as a 23, okay? So transport layer पर आज पैकेट આવ્યું છે એને ખબર પડશે કે એપ્લિકેશન લેયર પર ઘણી બધી એપ્લિકેશન રન થાય છે, પણ એમાંથી કયા સર્વરને મારે ડેટા આપવાનો છે, તો જેનો પોર્ટ નંબર છે 23. So by that way the transport layer can deliver data to the application layer, okay? So what is the meaning of encapsulation and decapsulation? So standard બાજુ જે આપણે header add કરીએ તે પ્રોસેસને કહેવાય encapsulation, અને receiver બાજુ જો header remove કરીએ તો તે પ્રોસેસને કહેવાય decapsulation, okay? બીજી રિસ્પોન્સિબિલિટી છે નેટવર્ક ટ્રાન્સપોર્ટ લેયરની મલ્ટીપ્લેક્સિંગ અને ડીમલ્ટીપ્લેક્સિંગ, okay? So multiplexing કોને કહેવાય? So whenever an entity accepts items from more than one source, okay? Whenever an entity accepts item from more than one source, this is referred to as multiplexing. જે રીતે આપણે physical layer માં જોયેલું multiplexing, that we can receive the data from multiple devices, then we can create a single message that will send to the receiver. The receiver will perform the demultiplexing, in which based on the particular process, here based on the particular process, they can separate out the message and deliver that packet to the particular process, okay? So the process of combining the multiple packets at the sending side, and this process is known as the multiplexing, okay? અને જે single packet આવ્યું છે એમાંથી based on the process we have to separate out the various packets, okay? So this process is known as the demultiplexing, okay? So the transport layer at the source performs multiplexing, while the transport layer at the destination performs the demultiplexing. So for example, you can see here that we have the application layer at the source side or the client side, which is running the three processes, okay? Suppose આપણે client બાજુ આપણી ત્રણ પ્રોસેસ રન થાય છે. લેટ્સ સે કે અહીં છે આપણું એક છે જીમેલ સર્વર, ઓકે? બીજું છે લેટ્સ સે આપણું છે ગૂગલ સર્ચ એન્જિન, ઓકે? અને ત્રીજું છે, okay, so third one is also we are using one mail application, okay? So this P1 and P3 using the mail application, while P2 is using something searching, so it requires the HTTP server, okay? So P1 અને P3 ને જોઈએ છે SMTP server mail માટે, while P2 ને જોઈએ છે HTTP server searching માટે, okay? So P1, P2 અને P3 ત્રણ મેસેજ જનરેટ કરશે, M1, M2 અને M3, okay? So P1 નો મેસેજ છે આપણો M1, P2 નો મેસેજ છે આપણો M2 અને P3 નો મેસેજ છે આપણો M3, okay? So transport layer where we have the multiplexer. So multiplexer શું કરશે? So based on the process ID, it will find out the route of the packet, okay? So it will find out that P1 and P3 are for the same type of server, okay? So P1 and P3 want to communicate with this server, while P2 want to communicate with this server, okay? So here this P1 and P3 are combined into the single segment, or we can say that single message, and delivered to the transport layer of this server, while this packet 2 is delivered to the transport layer of this server, okay? At the transport layer of this server we have the demultiplexer. So demultiplexer will separate out the packet 1 is for this process, while the packet 3 is for this process, okay? So matlab, if we have the same type of server, then we can combine the several type of packet into the single message and deliver to the transport layer. So combining the several packets into the single one, this is known as the multiplexing, while separating out the various packets based on the process ID, that is known as the demultiplexing. Okay. બીજી responsibility છે transport layer ની flow control. Okay, so we know that flow control means the controlling the rate of transmission at the standard side. Okay, so controlling the rate of transmission at the standing side. So here we can say that here we have the application layer of the sender. Here we have the transport layer of the sender. Same way, here we have the application layer of the receiver, and here we have the transport layer of the receiver. Okay. There is a communication between the application layer of sender and the transport layer of sender. But we can say that these are the push delivery. Okay. The communication between this application layer and transport layer, it is a push delivery. That means application layer पर जे कई पण process run થાય છે, that will generate some message and then it will directly deliver to the transport layer without worrying that transport layer is ready or not. Application layer पर जे कई पण generate થાય, that all things will be delivered to the transport layer. Okay. So and second thing is there is a communication between the transport layer of the receiver and the application layer of the receiver. Okay. But it is a full delivery. It is a full delivery. Matlab whenever the process on the receiver is ready to receive. Okay. For example, જ્યારે આપણું server ready હોય ત્યારે જ we can deliver our message. For example, કોઈ વાર આપણે જોઈએ કે આપણું server down હોય, then we cannot deliver our data. Okay. So that means we can say that it is a full delivery. मतलब जो server ready હોય તો જ આપણું packet accept થશે. Otherwise it is going to be rejected. Okay. So same way the transport layer of the sender and the transport layer of the receiver, it is also a push delivery. That means standard and transport layer पर जे कई पर generate થાય છે, that is directly delivered to the transport layer of the receiver. Okay. So that means we can say whenever we have the push delivery, मतलब जे कई पण standard પાસે generate થાય છે, that everything will be delivered to the receiver. Okay. For example, here the standard is application layer, receiver is the transport layer. So मतलब application layer पर जे कई पण generate થાય છે, that is delivered to the transport layer. Okay. So when we have this such type of application, or we can say that when we have the push delivery, we require the flow control. मतलब transport layer पर જ્યારે આપણો data વધી જાય, we should inform the application layer that now you should be slow down. Okay. Same way, here we have the push delivery between the transport layer of sender and transport layer of the receiver. So here also we require the flow control. कि suppose receiver बाजू data वधी जाए, we should inform the sender that you should now slow down. Okay. So that means the flow control is between the application layer of the sender and the transport layer of the sender, while the flow control is again between the transport layer of the sender and the transport layer of the receiver. Okay. So you can now have a second question that how we can decide that the transport layer is burdened, or we can say that the transport layer पर આપણો data વધી ગયો છે, એ આપણે કઈ રીતે sender ને inform કરી શકીએ. Okay. For example, suppose અહીંયા transport layer પર overhead થઈ ગયું છે, કે transport layer is not able to deliver the data to the application layer. That means we can have more number of packets at the transport layer. So we should inform the transport layer of the sender that now we have to slow down. Okay. So how we can inform this thing? So for that they have provided one more thing that is known as the buffers. Okay. So we are using the two type of buffers, one at the sending transport layer and other at the receiving transport layer. Okay. So what is buffer? Buffer is nothing but we can say that it's set of memory location that can hold packets at the sender and receiver. Okay. So buffer is nothing but we can say the one type of memory location that can be defined at the sending side and at the receiving side. Okay. So let's say we have we are using the buffer that is equal to the storing the one packet. Okay, આપણે અહીંયા એક એવો બફર મૂકી શકીએ that can able to store only the one packet. Okay, so what we can do is જ્યારે આપણું આ બફર અહીંયા ખાલી થાય, at that time we will inform the transport layer that now you send the data. Okay, જેવું આપણું બફર full થઈ જાય, at that time we'll inform the sender that now you stop. Okay, બફર ખાલી હોય ત્યારે સેન્ડર ને કહેવાનું કે હવે ડેટા મોકલો, અને બફર ફૂલ થઈ જાય ત્યારે સેન્ડર ને કહેવાનું કે ડેટા મોકલવાનું બંધ કરો. Okay, so using the buffer approach we can provide the flow control mechanism. Okay, generally the first mechanism was using the buffer that is the size of one packet. Okay, we can have buffer that can store only the single packet. Okay, but like our stop and wait ARQ માં જોયેલું, that idea is we can at a time we can send only the one packet. Okay, so જ્યારે આપણું when we got the acknowledgement, the sender will send the data. Okay, so that one packet approach is not good for the transport layer. The thing is it will create the more number of packet within the networks. Okay, so what we can do is we can create the buffer that can store the multiple packets. For example, transport layer બાજુ આપણો એક એવો બફર છે કે એક સાથે 5 પેકેટ ને સ્ટોર કરી શકે છે. ઓકે, તો સપોઝ સેન્ડર બાજુથી 5 પેકેટ આવે છે. ઓકે, સો જ્યાં સુધી 5 પેકેટ થી આખો બફર ફૂલ ના થઈ જાય ત્યાં સુધી it will not send any signal. ઓકે, જ્યારે 5 પેકેટ થી આખું બફર ફૂલ થઈ જશે, at that time it will inform the sender to slow down. Okay, while જ્યારે આખું બફર ખાલી થઈ જશે, at that time it will inform the sender to retransmit, it will inform the sender to again start the transmission. Okay, so by that approach we can provide the flow control at the transport layer. One more responsibility of the transport layer is error control. So error control at the transport layer is responsible for detecting and discarding the corrupted packets. Okay, मतलब जे पैकेट that if some of the data is going to be changed during the transmission, so we need to remove such type of packet from the networks, keeping track of lost and discarded packets and resending them. Okay, so also we need to track that suppose 5 પેકેટ મોકલાવ્યા છે, એમાંથી કયું પેકેટ લોસ થઈ ગયું છે અને કયું પેકેટ ડિસ્કાર્ડ થયું છે. So again sender had to retransmit that packet again. So that type of information also can be done by the transport layer. Recognizing duplicate packets and discarding them. Okay, if there are some duplicate packets at the receiving side, we should able to find out that this one is the duplicate packet and we need to remove them. And the fourth one is buffering out of order packets until the missing packet arrives. Okay, for example, let's say કે એક મેસેજ માંથી આપણે 5 પેકેટ જનરેટ કર્યા છે. ઓકે, તો સપોઝ જીમેલ માંથી આપણે કોઈ મેસેજ મોકલાવ્યો છે, એનાથી આપણે 5 પેકેટ જનરેટ કર્યા છે. ઓકે, તો રિસીવર બાજુ જ્યાં સુધી પાછી 5 પેકેટ આવી ના જાય ત્યાં સુધી we have to wait. ઓકે, સપોઝ પાછી 5 પેકેટ આવી ગયા, then we have to create the message and deliver to the application layer. Okay, તો જે 5 પેકેટ માંથી કોઈ પણ એક પેકેટ ના આવ્યું હોય ત્યાં સુધી એને બફરમાં સ્ટોર કરવાના. That can also be done by the transport layer. Okay, so how we can do that thing? So we know that we have the idea of the sequence number and the acknowledgement number. We have seen this thing on the data link here. That means for every frame we are sending the sequence number, and in the response of the sequence number we are getting the acknowledgement number. Okay, so error control requires that the sending transport layer knows which packet is to be resent, and the receiving transport layer knows the duplicate or which packet has arrived out of order. Okay, so this can be done if the packets are numbered. So we can add a field to the transport layer packet to hold the sequence number of the packet. Okay, मतलब जे कई पर पैकेट जाता है, so जे कई पर पैकेट जाता है, that all packet we have to assign the sequence number. And same way we require the acknowledgement number. मतलब रिसीवर बाजू से आपको acknowledgement number आवे, that also we need to give the numbering. Okay, but we can't use that method of the sequence numbering that we have used the stop and wait ARQ. Okay, so in the stop and wait ARQ, we have used the modulo 2 arithmetic, in which we have only two values, that is the 0 and 1. Okay, so first packet is 0, second is 1, third packet is 0, fourth is 1, like that. Okay, but here we need to handle the multiple packet at the same time. So we need to include the sequence number of each packet in the header. So we need to set a limit. Okay, so for example, let's say our packet ma header is size say m bit, then the sequence number can range from 0 to 2 raised to m minus 1. Okay, so if m is the 4, suppose આપણો 4 બીટ નો હેડર છે, તો 4 બીટ નો હેડર હોય, 4 બીટ નો સિક્વન્સ નંબરની ફિલ્ડ છે હેડરમાં, તો સિક્વન્સ નંબરની વેલ્યુ ક્યાંથી ક્યાં સુધી આવી શકે? સિક્વન્સ નંબરની વેલ્યુ આવી શકે આપણી 0 થી લઈને 2 raised to 4 minus 1, so 0 to 15. Okay, so we can have we can number total 16 packet. The first packet is 0 and the last packet is 15, and again we can start the sequence number from the 0. Okay, so we also need to require some mechanism in which suppose આમાંથી કયા પેકેટ સેન્ડ થઈ ગયા છે અને કયાનું acknowledgement આવી ગયું છે. So for that we require this sliding window. Okay, so here this blue part indicates that 0, 1, 2, 3 packets are sent. Okay, and 4, 5, 6 હજુ send નથી થયા. Okay, suppose આપણું ચોથું send થઈ જાય, so your sliding window માં that fourth is also tick mark. That means 0, 1, 2, 3, 4 all are sent. Let's say 5 and 6 point sent થઈ ગયા છે, so we can say that the everything is now blue. Okay, so that means when everything is now blue, then your sliding window will move to the one frame, or we can say that one position. Okay, so પહેલા start હતી આપણી 0 થી. Okay, so now you can say that now your sliding window is starting from the 1. So we'll see that thing in the next lecture.